Is there anyone? Oh, okay, one person. We love you, man, so we go in English. Okay. So, still, for today, who's traveled the longest distance? Like, who is not from Batumi? Oh, one. Okay, no, I mean, like, right, who is not living in Batumi right now? One. Okay, 2, 3, perfect. Where are you guys from? I mean, like, from which location did you travel here? Sorry? Okay, 15 minutes.
40 minutes.
40 minutes, okay. Anyone more? This morning we were in Oni, like very north of Georgia, and it was like such a beautiful place. Caucasian mountains, that's just like really breathtaking. But it was quite a long flight for, I would say, overall 6 hours we transitioned from Germany to enjoy Georgia and to enjoy meeting new people. And thank you all for coming. The most precious thing we have is a time, and I'm proud you trust your time to me. It's a very smart investment. You will see it soon. So, should we start? Perfect. Then I will need my slides. Okay. Perfect. So the name of the event is NoSQL Special Batumi. And the first thing I want to start here is I have to ask you, please stop using NoSQL. At this point, you might be asking, like, this guy is crazy. He invites us to NoSQL Special meetup, and then he says, like, we shouldn't use NoSQL anymore. Yes, that's exactly what I do. And if you think like I'm not perfectly sane, it's fine for now. Give me 15 minutes, and we will see who is sane. My formal job title is Head of Developer Education at DataStax, so I'm responsible for training developers to use decentralized NoSQL systems. But actually my real title is IT exorcist. My job is to expel some miscommunications, misunderstandings from software development teams. That's what I do. That's my real work. And I have to tell you what NoSQL deserves to be expelled. Please raise your hand if you understand database management systems. Поднимите руки, если вы понимаете, что такое СУБД. Давайте, господа, здесь все айтишники. Everyone is from IT. How many software developers do we have, actually? How many DevOps operations do we have? Okay, good. Perfect. Keep your hands up if you have used relational databases. Well, quorum, well, majority, perfect. Very well. Keep your hand up if you have used NoSQL databases. So quite some people. That's good. That's pretty helpful. Please keep your hands up if you understand what is NoSQL. And notice my hand is down. I work in software development and development operations for like getting close to 20 years. And I still don't understand NoSQL. This year I'm becoming an Apache Cassandra committer, official Apache Software Foundation committer member. And I still don't understand what is NoSQL. So you might be of help to me. What exactly is NoSQL? Is it a database? No. Is it a query language? No. Interesting point. Wikipedia gives no formal definition to NoSQL. You open any page, like whatever thing you want to learn from Wiki, and you immediately get the answer like, what is laptop? Laptop is a computer device with a display, like for personal use normally, these kind of things. You open NoSQL, there are no formal definition. And I think I know why. First, you will have to help me a little bit. Please define those three objects. This one, and this one in one word. Cars, right? It was easy. Simple as that. Cars. Yeah. Now please help me with those three. This one, and this one. One word.
Machine, vehicle,
Vehicles, yeah. If we go with English, I would use vehicles. There are some options, but yes, I would go for these. Those are totally different, right? So those are totally different. Submarine, motorcycle, that's my motorcycle, by the way. And, well, space shuttle. So, but still those are transportation means, right? Let's get harder. Like, there are so many bright people here. Please define the same three vehicles in one word. So, it will exclude cars. I will remind you, those three devices, objects, but no cars allowed. Word vehicle doesn't work anymore. Again?
toys.
Toys? Well, okay, I wouldn't call this guy toy. That not would be my word. It's not really...
Some kind of vessels.
Vessels? Well, vessels, we can consider car as a vessel. Problem. So, there is no simple answer, right? Why? What, it should be something like vehicles but no cars? Sounds pretty stupid, right? Well, like why don't we have word like that? Why? Because we don't need it, actually. Why don't we have vehicles but no cars word? We don't need it. That's exactly what NoSQL is. Seriously. All databases, except relational, SQL compatible. Because there are some relational databases what aren't SQL compatible. And fun fact, first NoSQL database was relational. It just didn't support NoSQL. So, what are the databases behind this stigma? I like this word, like it's perfectly matching. NoSQL is a stigma. That's why we should stop using it. Document databases. Mongo. Like, how many of you know Mongo? Yeah, I mean, like, really a lot of people, of course. Key value, like Redis, for example. Graph databases, Neo4j, DataStax Graph, AWS, Neptune, I believe. White column, like Apache Cassandra. Time series, like Prometheus. Ledger, like AWS Ledger, for example. And there is a little problem with them. Yeah, and many more, but there is a little problem with them. They are totally different. You tell your colleague, we will use NoSQL. It gives nothing. It just gives nothing. What NoSQL? Mongo? Cassandra? Maybe, I don't know, Neo4j? Let's go to Tbilisi, buy any vehicle but no car. Now you are happy? What it will be? Motorcycle? Space shuttle? Submarine? It's going to be hard to go to Tbilisi on submarine, I guess. But you know, like, with enough power and violence, we can solve it. Kinda. When we speak about those databases, we speak about, for example, Redis. Redis is a very good, very performant database. Well, some people don't agree it's a database per se, but still, it stores data. Key value pairs, very fast. Had some problems with persistency before, but not about that. It's very good for storing symbol combinations, some kind of a cache, like these kind of things. Neo4j. Neo4j is a great graph database, maybe most widely used graph database in the world. What makes a really good connection, like if you want to investigate not just entities, but relations between them. That is a great thing, totally. Fun fact, graph databases are even more relational than relational, because in relational databases, actually relations are second-class citizens. If you think about that, relation cannot have properties, you cannot even fetch like then it was created, basically. You just or have foreign key or you don't. Simple as that. In graph databases, relations are kind of as first-class citizens, as important as Neo4j%. As entities, they have properties. You can have multiple of them. Like it's a very, very cool thing for work with data. White column databases like Apache Cassandra, we will be talking about a lot today. All about performance over billions, like really over petabytes of data. On multi-region deployments. Very cool database with a lot of pain in it, you will see soon. What do those databases have in common?
Nothing.
They store data, very different data, in completely different way. So, why do we group them? NoSQL is harmful, and I perfectly mean that. I mean that NoSQL is harmful. Word. Literally, any statement NoSQL is or NoSQL does is wrong. Literally, literally any statement is wrong. Except NoSQL does not support SQL. Well done. Take a look. NoSQL is schemaless. I do a training for students, overall 3 hours, introduction to NoSQL. We speak about very many different databases, how we store data, how we work with data, how do you like store, retrieve, what's like the internal differences, and we speak about very different databases. In the beginning, I asked them, how many of you think what NoSQL is schemaless? Well, you know, like Mongo. Around 70 to 80% say, yes, NoSQL is schemaless. Okay, I mean like students, beginners, perfectly fine. 3 hours later, we are creating tables, we are defining schemas, we are working with relations and strict schemas in graph databases, all these kind of things. And I ask, do you think NoSQL databases are schemaless? What do you think? 30% answer yes. What the hell, guys? I just spent 3 hours with you. Really, I should quit my job. So, NoSQL is distributed. That's a common mistake of my colleagues. Those great professionals, but we use it to work with Cassandra. Cassandra is distributed, so we say NoSQL is distributed. Bullshit. Mongo is not distributed. And there are plenty of non-distributed databases. NoSQL is better than SQL. That's my favorite. That's a complete bullshit. SQL is great. It stays with us forever. So yeah, it makes me very sad. Don't make me sad. But then it kind of makes sense to ask, right? What do we say then if you don't plan to use SQL? What do we tell to our colleagues? How we discuss that? We don't plan to use SQL. What do we say? Guess what? You've seen this slide already. Document. You say document if you plan to use document database. You say key value. You say graph, white column, time series, ledger. Special purpose-built databases. Before it was enough to know SQL. Fine. This time is over. Now we need to know more. Before, humanity was like generalized. Each and every person was a hunter, a gatherer, farmer, depending on the region. I mean, like, but you get my point, yes? There were no specializations. Over time, humanity developed specializations. Now we have drivers, IT specialists, IT application owners, software developers, DevOps, I don't know, even doctors now, like how many hundreds kinds of different doctors we have. Specialization is cool. Specialization helps. Exactly the same happened with the databases. So, we need to learn more to be better. It was enough to know how hammer works. Now we need to know much more to be good engineers. We have to learn more, but you know what? It's well paid. So sounds kind of fair to me. Please stop NoSQL. Word. Use purpose-built databases. Those are awesome. Yeah, and we come to the second part. If you want to get beer or whatever, then it sounds good to me. If you are good, then we can proceed. Can we do something with conditioning or ventilation maybe here? A little bit too hot, or am I just... It's fine for you? Yeah. You have enough air? Good. Good, then let's keep moving. I will start then the second part. And I hope, like, what is the most important point of this presentation? Like, is there anyone who thinks NoSQL is schemaless? Keep your hands down. Don't give me the reason. Good. Sounds good. Then, let me switch. Oops, wrong side. Yes. Good. So, silence. After I did this Please Stop NoSQL talk as a keynote talk at Cassandra Day Hanoi, Jakarta, and Singapore, and reaction is like of two different types. First kind of reaction, people just laughing and laughing and laughing, like barely breathing. Second kind of reaction is a complete silence. You know, I actually like silence more, because silence means you're thinking, and that is great. That's exactly what we need. And laugh, well, laugh is cool, but you know, it's not a stand-up comedy. Sorry, by the way, next time maybe. But yeah, let's go with Apache Cassandra. So, question. Please use your mobile phones, open menti.com and enter this code, or just scan the QR code on the screen. I will give you some seconds. Yes, you are jumping in right now. 9768824 menti.com. Okay, people are jumping in. Perfect. Let's move them. Anyone need a second more? Good, good. A code will be on top of the screen, so you can enjoy later. I want to keep moving. We are speaking about very, very important things today, so let's keep the pace. What's your experience with relational databases? I need to understand you better. I need to know you. Perfect, perfect. Okay. People with zero relational database experience, it's going to be a little bit rough for you, because like we are covering pretty advanced topics today, you know. But yeah, that works. That's quite a good distribution. I'm lucky. Then your experience with NoSQL databases. It's an old presentation. I have to delete this word. Little, known, known, little. Okay, good. And finally, the database you use the most. I guess I know the answers. Usually I do. But well, try to surprise me. Postgre, well, sure. DynamoDB, oh, okay, cool. Postgre, Dynamo, Postgre, Dynamo, SQL Server, oh, poor guy. Okay, MS SQL Mongo. What was that? Tarantul, oh, cool. SQLite, well, do we count it as a database? But okay, yes, sure. For people working with Dynamo, Dynamo is kind of based on the same white paper as Cassandra we will be talking about today. So some concept might be familiar to you, but still, I hope I will keep it interesting. Do not close Pentium, we will need it, but you can move it away for a moment. Oops, wrong side, yes. Good. So, first thing first. Now, everyone in my company says, teach people how to use it. No one needs to know how it works internally. Bullshit. Then you just know how to use a tool. You are not better than a monkey pushing red button than the red light blinks. Seriously. You need to understand how it works internally. That's what makes engineers, and I hope we are engineers. Very important disclaimer. Don't try this at home. No, actually that's a lie. Please try this at home, but please try it at home, not in the production servers, okay? We are speaking about advanced technology, advanced. So be very careful and don't destroy your production by wrong clicks. It's very easy to do. Using Cassandra, pain is inevitable, suffering is a choice. So let's move on. Have anyone heard about func-driven development? Now it's going to be manga-driven development. Nope. Func-driven development is a kind of a development. Then you use projects, then you add some tools, databases, for example, into your architecture, because Facebook or Apple or Netflix are using them. And that's a disaster. Please don't do it. I've seen it so many times. Google is using microservices, so we will do. Guys, if you cannot create a reasonable monolith, you cannot create a good service-oriented architecture or microservices. I'm sorry, but that's tough. CV-driven development. Anyone heard about that? Yeah. CV-driven development is then you add some tools into your project because you want to have them in your CV, in your resume. Basically, I consider it as a crime. Seriously. That's not fair. I mean, if you're getting paid, well paid, then don't do it. If you're not getting well paid, change your job and still don't do it. Please don't do this. And finally, great power comes with great responsibility. Cassandra is the most powerful database at the moment. But you really need to learn how to land before taking off. If you are first taking off and then trying to read the user's owner manual for Boeing 787, landing isn't going to be nice. So, how it's all started. In the year 2008, Facebook reached their first 100,000 users. That's tremendous, right? Like by now, there are plenty of companies of a size much bigger than that, but it was year 2008. That was something new. That was totally new. They basically experienced the problems no one experienced it before. And it was not only about the size, but about the new requirements. Take a look.
100 million or 1,000?
Oh, sorry, 100 million. It was a long day and even longer night. So, situation. Users around all the world, truly global company. It wasn't a thing before. Like, okay, there were global international companies, but each one was operated by like local headquarters, and they weren't truly distributed. Users all around the world, all the continents, maybe except penguins, I don't know. Fast internet connection, it's a game changer. Before, no one cares if your database is fast or slow. Because still last mile internet service provider is a real problem. With fast internet connection, your database became a bottleneck. A lot of data, much more than any project before, and also very strict high availability requirements. Database must be available all the time. And there were a little teeny tiny problem. There were no database to answer those requirements. That's the story that Cassandra starts. But you know what? Before we proceed with speaking about Cassandra, I want us to think as architects, because actually that's what we have to do as software engineers. And we start with defining requirements. We need to understand requirements. If you don't know where you're going, every road will lead you nowhere. So we start with the requirements, and based on these requirements, we will make architectural decisions. And what's our requirements? Geo distribution, users all around the world. Volume, we speak about petabytes of data, we speak about millions of queries per second. We need immediate response, single-digit millisecond. And we need availability, well, basically up to 100% uptime. And yes, there are some companies having 100% uptime on their database. It's possible. What brings us to a story? How do we use those requirements to define, to build our architectural decisions? First, geographical distribution. Your database cannot be fast. Application will not work fast if your customer is in Australia and your database in Batumi. Like, we still have speed of light, sorry. We still cannot beat speed of light. Maybe luckily, I don't know. But still, we need to have multiple active data centers. Notice the word active, it's actually a big problem. Many databases can do active-passive replication. So you have one data center you can write and read, and all the others, passive, so you can read only. So kind of reading data is fast, but writing data, you still need to write to Batumi from Australia, and Australians and kangaroos are not happy. So with multiple active data centers, we will be pretty good on this side of the things. Then volumes, we are going to have really a lot of data and millions of queries per second. That brings us to a very simple, like we have no other option. We have to split our data into chunks. We cannot have a single server what will store this data. It's just not possible. There are no server to answer those queries, millions and millions and millions of queries per second for petabytes of data and still handle it like within single-digit millisecond. Nope. So, time. We need answer immediately. So what? Denormalization. Denormalization is pain, but that's what we need. And for partition-based routing, I will discuss soon. And for high availability, we going to use replication, decentralization, and again, multiple active data centers are very helpful. You remember what I was talking about in the beginning, from generalization to specialization. So how it goes with the databases. Why relational databases dominated the market for like, I don't remember, like 50 years, right? A bit less, 40 years. So for literally dozens of years, we were using SQL databases and they were perfectly enough. Why? Because they are multi-purpose, versatile enough to stay on both OLTP and OLAP side of the things. But what is it? Like anyone understands those words, OLTP, OLAP? Okay, okay, good. But let's explain it. So OLTP side of things, easy to explain with customer facing. Смотрит, господи, customer facing. Да, здесь по-русски, наверное, лучше не скажешь. We have a lot of operations. We have very strict SLAs on availability and response time. But, and that's very important. We cannot afford being slow. If we are slow, our customers will switch to our competitors. We will make less money. We are not happy. Investors are not happy and all this shit. I don't care a lot about investors, but I do care about customers. Then on another side of things, we have OLAP databases. OLAP workflows, we're better to say. It's a different story. OLAP database stands for Online Analytical Processing, and it's about data exploration, very complex queries, analyzing historical data, analyzing customer behavior. And there is a principal difference. OLAP data usually, OLAP kind of workloads usually are created by our analysts, and they're getting money so they can wait. Customers paying money, they cannot wait. By the way, fun fact, complex queries. Try to guess how many, in MySQL version, I believe 5, it was like 6 years ago, maybe even more, what was the biggest amount of joins in a single select statement? Try to guess. Sorry? Again? Where? In where cloud, yeah, how many joins you can have in MySQL in version 5, I believe. 100, anyone else? Any more attempts? Okay, good. So, 61. You know how I learned that? You guess? You guess? Yeah, exactly like this, I got an exception. You cannot have more than 61 join in your fucking query. And can you imagine maintaining this shit? It was painful. Yeah. So that's a typical OLAP thing, counting things from dozens of tables with very complex search queries. On OLTP side of things, you cannot afford it because it's obviously going to be slow. So OLAP data, relational databases are here. They're versatile. As long as you can, as long as you need versatility and can afford it, it's great. But even more data you have, faster answer you need to have, at some point you need to go to specialization. And as soon as you start to move somewhere, like using tools specialized for OLTP or specialized for OLAP, it's going to be great on this side and going to suck on that side. So, they desperately needed distributed, decentralized OLTP database. And by now, it's year 2023, I hope. What's the status of Apache Cassandra? That's what started in Facebook in 2008, how it looks right now. Last year, Apple reported what they run over 300,000 database servers, storing hundreds petabytes of data, over 2 petabytes per cluster, serving millions of queries per second. They do not say exact numbers because their legal teams, security team are like very strict. If you want to have Apple speaker on your event, like I did, you are going to invite them 3 months in advance because we will spend 2 months getting allowance to go and talk about whatever open source they are using. And still there will be many restrictions. My favorite guys are Netflix actually. If you use Netflix, you use Cassandra. Just don't know about it. You use Apple, you use Cassandra. On most active single cluster last year, Netflix reported 30 million operations per second. And like they also speak about hundreds petabytes of data. So that's quite some numbers. If you are interested, we have this talk, Cassandra at Netflix, cloud database architect from Netflix, Vinay Kumarchella, did a very good talk. I personally asked him to do so because, well, we need to know more on how it goes. Again, best thing, what actually those, not just users, they're developers. Biggest improvement for Apache Cassandra happening this year was actually implemented by Apple and University of Wisconsin. Those are great guys collaborating and, well, we're working together. I love open source. Question. I hope I distracted you enough. Jump in, get ready. Ready. Start your engines. Okay, so let's go. Question. Cassandra is best fit for OLTP workloads, OLAP workloads, both types of workloads. I need some music from like maybe horror movie or some thriller, definitely like something suspense. Yeah. Right, OLTP workloads. Both types of workloads. People, not possible. There are no silver bullet. You can get a Formula 1 car, you can get a truck, but you better not put your truck on a Formula 1 race, right? It won't work. There's basically no database what would be a good fit for both types of workload. Not possible. OLAP workloads, no, there are some kinds of OLAP kind of workloads what will be a good fit, but no, in general, yes, OLTP workloads. Well done. So, how it works internally? Because we are engineers, we need to understand under the hood things. Partitioning. We split data into chunks. We don't split all data on a single server. It's just not possible. We go with partitioning, so we spread the data over multiple servers. Very interesting hint for scalability. As we split data into chunks, we can have more and more servers and data will be moved to them in a smaller chunks, so it's very good for scalability. Read-write performance is like top of the world. Here it's one of the fastest databases for sure. And with the scalability, there is a special thing, like very, very tasty thing. There are plenty of databases what scale for reads. It's not so hard with master-slave architecture. Oh, like I love speaking in Europe, because if I would say something like that in the United States, they would fire me. Well, not fire, but I would definitely get some problems, maybe cancelled or what. So, many databases scale for reads. But for writes, no, it's not work like that. For writes, it's hard. Cassandra scales horizontally, scales well for both volume or velocity, so amount of queries per second, but best of all, it scales linearly. This research was done by Netflix some years ago. They scaled Cassandra cluster from 50 servers to approximately 300 servers, measuring writes by node, replication factor 3, I will explain later. What's the best thing here? Not just performance improve, that's obvious, but this line is basically straight. And that's what our databases cannot do, because scaling up, even scaling out for many databases, actually brings you somewhere here. Why? Because of overhead per node added. You add more nodes, you get less and less and less until you get nothing. So Cassandra scales linearly, but do you see this mark? If you see this mark on a like official document, on a contract, rental contract, you're buying a car, or maybe bank loan contract, you're going to be very careful, right? Because like there's a very teeny tiny letters in the end what may change a lot. So short answer is Cassandra scales linearly, but it's a shared responsibility. Cassandra will do its job. But what you have to do is you need to do your data model right. We will be talking about that today, but actually there is a problem. Our course on data modeling for Apache Cassandra is around 8 hours, and we don't have 8 hours, yeah? we can start right now, we can do a full data modeling course. We'll be done by tomorrow morning. Do we go for it? Thank you, sir. So, nope, not today. Invite me again, I will be happy to come. Let's go. Highest availability, how we make it. First of all, multiple live replicas. All data has to be stored in different multiple locations, geographically different locations. No single point of failure. What does that mean? Master-slave architecture gives you single point of failure. Master. Yes, you can have failover, switchover, all this shit, but you better don't have single point of failure at all. Yes, network topology data replacement. Oh, that's a long story. Also, client-side smart reconnection and strong retry mechanism. So drivers basically capable of switching to another node or to another data center if first one failed automatically. Operations were developers, so this part of this slide might be not so interesting to you, but for me it means a lot. I'm a very lazy guy. I don't like, if I can avoid work, I will avoid work. So operations for Cassandra clusters, and those clusters can be really huge. It's pretty hard, actually, really a lot to do, but Cassandra clusters are very smart, so self-healing and many operations are totally automated and don't require human presence or work for that. For some of them, you need to get an allowance, like push the button, okay, you can go on, but still, because like you don't want to do some kind of things in the wrong time. Let's go. So, geographical distribution, already discussed it, and all data centers are active. My favorite part is platform agnostic and vendor independent. Platform agnostic, that's pretty clear. Like who was using DynamoDB? I remember in the beginning, 1, 2. Okay, so DynamoDB is a cool thing, but if at some point you decide to migrate to GCP, you're fucked up. So, Cassandra is platform agnostic, you can run it basically everywhere. And my favorite part, vendor independent. So it's not, it was produced originally by Facebook, it then was kind of adopted by DataStax, it became Apache Software Foundation project, and it's open source software foundation, non-profit software foundation, what you definitely know by now, like Hadoop, Spark, Kafka, all these kind of things you might be using. Good. Proud member of Apache Software Foundation. So where is the catch? Cassandra is so cool. Where is the catch? Yes, there is a catch. It's, as I said already, it's distributed non-relational OLTP. Gesundheit, bless you, будь здоров. No joins, so you will have to denormalize your data, and then, guys, that's not actually easy. That brings a lot of problems. You must understand the partitioning and routing by the partition key, and that creates, guess what? A lot of problems. Very limited search capabilities. If you really need to search and analyze your data, mostly probably you will need to have even more advanced solutions, so you will need Cassandra for OLTP kind of workloads, and meanwhile stream data, for example, with Apache Pulsar, with Apache Kafka, to some another database, I don't know, maybe Elasticsearch or whatever, Apache Spark you would use for analysis, for search things, this kind of, requires qualified personnel. Girl from my team in DataStax was basically bought out by Apple, and we cannot compete with Apple. Just like if they want to hire someone, they go and hire. Good for us. I mean, like, are there any managers, directors, CTOs? Nope, nope, nope. Good for us. So it means we are getting better paid. Sounds good to me. Question. Раз, два, три. Tell me, please, how do we scale Cassandra cluster? I didn't discuss a lot about that, but let's try to guess. Scale up by upgrading servers, scale out by adding servers. Cassandra cluster does not need scaling. That's pretty interesting. Everyone has voted, thank you. So, yes, perfect. Who did it? Who did it? Thank you. That would be great. Nope, sadly, it needs, and yes, it goes by scaling out. Very well. So, how it all works eternally, like very powerful features, dozens, millions of operations per second over continents. First thing, written in Cassandra Holy Book is the very first paragraph. All servers are created equal. What does that mean? There are no master servers, there are no slave servers. All servers are equal. Traditional architecture uses so-called leader-follower master-slave architecture, you know, with single point of failure, which is a problem, hard to scale for writes. For reads, you can scale easily with folders. For writes, it's pain. And application needs to know where to write. If you're going to try to write on a follower server, it won't work. You always have to write to leader server. Cassandra goes totally different way, like totally different way. Cassandra is a peer-to-peer architecture. Where each node is capable of handling each request. It doesn't mean it stores all the data, but if it does not store your data, at least it knows who stores. So it helps us with a query redirect. Scales both for writes and read, and application can contact literally any node. When your application starts, Cassandra Driver will contact one of the seed nodes to get information about a cluster schema. How many nodes do we have? Where are they? What are their IP address? And most importantly, for which piece of data those nodes are responsible. It takes some time in the beginning, so application start might take a little bit longer than usual, but after that, first of all, your application will contact node what is responsible for your data, so we avoid redundant network operations. And if this node goes down, we can just switch to the next one, to the next one, to the next one, in the end to the next data center. And that happens automatically. Well, automatic data center switch is not recommended for some reasons, but in general, yes, it's possible. Question, oh, so fast. But you know, I like to keep asking your questions. So, how many master nodes for a cluster? I hope you answer quickly. Minimum 3 per data center. Count of a follower replica divided by 3, no master nodes. Don't dare you. Don't dare you. Yes. Yes, perfect. No master nodes at all. Yes, thank you. So, let's go. Data is partitioned. People, it's a bless and it is a curse. For real. Let me give you an example. We have table. Cassandra is NoSQL and Cassandra is not schemaless. We work with tables, strict schema. Totally fine, it's not a crime. And we have sensors by network table per different networks, per sensor, temperature sensor, and current temperature. Some real shit is happening in California. Okay. So, how normally we store this data? Table is stored on the master server and also on followers if you have some followers. How it's stored in Cassandra? It will be stored like that. So data is split into chunks, call it partitions, and they are placed on a different servers. It's a great feature, what comes with a lot of pain. What are the benefits? You understand already. We have more and more data. It's fine. We just add some more servers, data being moved to a new nodes automatically, and we are good. Good to me. And about the pain, you will see soon. Yes. So, how it's happening? Why data is spread like this? Why not base it on some other property of this data? Because when we created this table, we declare it primary key, and first part of a primary key is a partition key, which is network. So you see, Idaho, Kansas, Alabama, California, Delaware, Florida, and so on. And of course, each server can handle many partitions. So, how it works internally? Very interesting story. We assign it a partition key. Partition key is different for different rows. Well, partially matching. There is a special mechanism called Partitioner. Modern Cassandra Partitioner uses murmur-free hashing algorithm. I really like the name, murmur-free. It's overall 6 mur. Looks like cat is happy. And then this murmur-free hashing algorithm gets whatever you give to it, like Hawaii, and makes an integer out of it. And this integer usually doesn't look like that. That's not 45. It's going to be like this, actually. But for the clarity, I will keep it like that. This converted hashed partition key, call it partition token. And then situation is actually pretty simple. For example, we have 4 servers in our data center. It's going to be each server responsible for quarter, 25% of your tokens. So token range 1 to 25, 26 to 50, and so on. Again, normally those integers not like 1 to 25. It's for the clarity. Good.
And what is
Yeah.
a small asterisk?
Uh,
There should be some catch.
no. It's just mark for myself to explain what actually it's not 100, but it's like 300 billion, something like that. Yeah. So it's marked for me. Yeah, good. So why partitioning? Because we need to scale out. Big data is a data what does not fit to a single server. Like, you know, there are plenty of big data definitions. My favorite one was invented by me. Big data is a data what doesn't fit to a single machine. Not really scientific, but well, at least simple, already something. So, splitting this data into chunks, we can spread them over dozens, hundreds, thousands of servers, adding more in needed. Some of you maybe understand sharding in relational. Who is there understanding? And who of you did sharding in relational? God bless you guys, you are lucky. You are dodged a bullet, just like really. It's a complete shit. So, how scaling works in Cassandra? In the beginning, we have 4-node data center with a quarter of all possible tokens per node. Then, for example, we are Netflix and we are streaming last episode of the Game of Thrones, and we expect everyone to go see that. So we are going to scale out in advance, and we are adding more node. So now we have 5-node data center. The mechanism happening called a token range recalculation. So we will have smaller token ranges per server, not a quarter, but only 20%. And then data is being streamed to new servers. It's happening live, it's not a downtime operation. It's actually very cool. If you would ever do sharding, yeah, you will understand what I mean. You will understand why I cry with bloody tears right now. So, and then last episode of A Game of Thrones is out, everyone is unhappy, no one is watching Netflix anymore. We need to downscale to avoid extra costs for scaling operations. So we tell to cluster, I'm going to take down 3 servers. I'm going to take down 2 servers actually, yes, because we still need some replication things. What happens? Token range recalculation, right? So now each server is responsible for 33% approximately of all possible tokens. Data is streamed back. We can take off 3 servers. Again, all operations are automatical and all scaling operations are live. There's no downtime. Question number 4. So, how is data for table distributed? Each server has all data, one table on one server, by partitions, by shards. This one must be simple. Yes, perfect, 100%. Yes, I love it. That's right, by partitions. Yeah, good. So, but that's a problem. It's not enough to fulfill our requirements. We define it in the beginning. To fit into our architectural decisions we did in the beginning, we also need to do some more things. Partitioning is cool for scaling, but not enough. It doesn't help us with high availability. So data is also replicated. Guess what? Exactly as partitioning, it solves some problem and introduces a lot of new. What is replication factor you saw earlier? Replication factor defines the number of nodes used to store each partition. So, for example, with replication factor 1, we will have this partition for forest sensor networks, for example, store it on one server. Replication factor 2, replication factor 3. Same data. We consume a lot of disk space, of course, but it's highly available. So, when we create a table, when we create a key space. What is a key space? Basically, like schema in Postgre, it's just a group of tables. Think of it like a group of tables with with the same settings. So we create key space sensor data defining replication. There are plenty on configuration we can give, but the thing we must define is replication. strategy and replication factor. What is replication factor? Is simple. So I have data center United States West 1, replication factor 3. Europe East 2, replication factor 5. Question: if this statement is correct and can be executed successfully, how many data centers I have in my cluster overall? Tricky question. Nope. Nope.
At least 5?
At least it's a count of servers.
Oh, I see.
It's a count of key spaces. No, 2 is not the right answer. Right answer is at least 2, because I can have a dozen of them. And still, they're just not mentioned there because I don't want my data to be there. So answer is at least 2. Sorry guys, it's tricky, I know. So, network strategy. Strategy, very simple. You have simple strategy, which is good for your laptop, bad for anything else. A network topology strategy, and this is a real hero. Then you do a backup of your data. Do you put this backup on the same device where you made it? No? You put it to some other place. I hope so. And if you are the best, if you are the brightest and smartest, you also test your backups. Like, yeah. But, so that's exactly what network topology strategy does. It puts data to your United States West Data Center 1, but on a different server racks if you are using your own data center, or on different availability zones if you are using cloud. How many of you are into the cloud? Like, how many people are running in the clouds? I saw Dynamo, so AWS mostly probably. What are you using?
AWS.
Also AWS. Okay, good. Cool. No one on GCP? Okay, good. Bad, I don't know. Yeah, that's it. So network topology strategy places your data into different places, like far away from each other, so outage of a server rack or availability zone will not lead to downtime. It's a real hero of the day. So this one we discussed. Yep. So now bringing it together, partitioning and replication. Actually, it's all implemented with token ranges. When you have replication factor 1, each node will be responsible for its own token range. Then you go with replication factor 2, token ranges are duplicated. It's responsible for its own token range and token range of its neighbor. Kind of neighbor, but at least they're from the same data center. So that's how it works. Then when you write some data, it arrives to some server. First, it's being converted. We are getting partition key and converted into the token. We see what token 59 is here. This server is not responsible for token 59. It's responsible for others, but it knows which servers are responsible. So we go here and identify them. It's not a live operation, it knows it in advance, because we cannot afford doing slow operations during write query. It has to be very quick, single digit millisecond. So we write this data to those 3 nodes, and operation is done. Data is stored on 3 different servers. Important, normally it never happens like this. Normally, write operation will go to this or that server. Why? Because Cassandra node, each Cassandra server, and actually each Cassandra driver understands data allocation in a cluster. It's called a token aware. So your application can contact any server and still get the answer, but in normal circumstances, driver will contact replica. Replica is a node what is storing data you are currently working with. So for different queries, replica server will be different. Good. That actually also creates a problem. When you work, for example, with AWS Lambda, anyone using serverless? Oh, perfect. So be aware, startup of a driver takes time, because driver gonna go get data, go get metadata about data allocation in the cluster. Cool. So you better switch off this thing. Distributed architecture, that is my favorite part. But first answer me a question. What is the biggest problem of replication? Oops. It should be, yeah, this one. Just a second. Launching. So, what is the biggest problem with replication? Increased disk space consumption. Don't rush. more network transactions, potential cross-node inconsistency. Now we will have a real talk. What is the biggest problem of replication? Oh my God, unbelievable. It's first time I'm seeing mostly correct answers here, because usually it's distributed more or less even with increased disk space consumption, like a little bit bigger usually. Like, amazing. Yeah, may I ask, how many people here are from St. Petersburg? 1, 2, 3, 4, 5. Okay, just curious. Sorry. Yeah, potential cross-node inconsistency. But take a look. Does replication leads to increased disk space consumption? Yes, it is. Yes, it is, but it's not the biggest problem. The story is, if you are running Cassandra, mostly probably you are good with money. So in these problems you can solve with money are not problems. Those are expenses, right? More network transactions. Again, yes, obviously, replication leads to more network transactions, but the cool thing is even software-defined network, so basically everyone in the cloud are using software-defined network, already so fast what it doesn't matter so much anymore, and those can be used in parallel, so it doesn't matter if you write to 1 server or to 3 servers or 5 servers, it's still, well, it does matter, but not as much as it could. But the real problem here is a potential cross-node inconsistency. I see people of experience here. Right, potential inconsistency. Then we update data. If one of the replicas didn't get this update, we can run the pretty nasty situation. And it's a big problem. Replication is a big problem. So, it's a big problem for any distributed system. I don't know if you're using cache, like two biggest problems of software development, variables naming and cache invalidation. And if you don't think it's like that, I'm kinda envious. Yeah, especially distributed cache, it's a fucking pain. Good. So, Cassandra, as any well-designed distributed system, has a layered defense mechanisms system to protect itself from the inconsistency. First, and I love it because it's fully automated, so you don't have to do anything, it just works out of the box. Hinted handoffs. Then this data arrives to query coordinator, and query coordinator coordinates with query to those 3 servers. One of them might be down. Whatever, scheduled downtime, fire, I don't know, aliens attack, shark attack, doesn't matter, node is down. So what happens then? Query coordinator stores so-called hint. Hint or hinted handoff is a persistent piece of data what's stored on disk, it will not be lost, and as soon as this node recovers, hint will be delivered to it. Again, that's fully automated, and servers, each servers in the system, they're communicating with each other, so they know what this guy went down, this guy went up, so we can stream hints now, and that's pretty cool. The only problem is hints are available for, I don't remember, it depends on the version, 3 to 4 hours. After 3 or 4 hours, they will be discarded. For a very simple reason, if you have have you heard of catastrophic failover? Then kind of solution of a problem leads to only worse problem in the end. I will talk about that a little bit later on CEP theorem part. So, we cannot afford streaming all the hinted handoffs at once. If we lost half of the cluster, a lot of data is being written, then half of a cluster recovers, all of those days of hints are being streamed to those, and clusters down in full. So no, hinted handoffs are automatically deleted after a few hours. There are different tools to recover consistency in this situation. So, what do we have? Hinted handoffs, just discuss it. Repair and read, we will briefly discuss soon. Consistency level, very important to understand for you developers because, well, it's a developer job. And repairs is admin job, so I will keep it for myself, okay? But, how many of you heard about CEP theorem? 1, 2, 3, 4, 5. Okay, cool. That's a pretty good number. really. Like you have quite elite software development here in Batumi, for real. Usually number is much lower. Good. Before proceeding to the theorem, let's talk about features it operates. Availability, consistency, and partition tolerance. With availability, everything is simple, so people usually understand that. Availability basically means uptime. You ask the question, you get the answer, we are good. Okay, a little bit harder. Consistency means no stale data. And I speak about cross-node inconsistency in this case. You ask something, you get the most recent value. If this recent value is not so recent, so it's stale data, system is not fully consistent or inconsistent, right? And finally, partition tolerance. That is a real shame. So many people, even IT professionals, don't understand what that means actually. If you just go read, I don't know, questions on Stack Overflow, you will find tons of bullshit about that. So, to understand partition tolerance, we need to first understand partitioning. Take a look. We have a data center of 6 servers. And there is a problem with a network. So, group A is isolated from group B. Group B is isolated from group A. And the most common misunderstanding here is people think what group B is isolated in full. No, it is available to customers, clients, or both group A and group B are available to clients, but not to each other. That is a network partitioning. If group B would be completely isolated from customers as well, it wouldn't be a partitioning. It would be downtime for this part of a group. That's it. So partition tolerance is a capability of a distributed system to survive network partitioning without running into split brain. And split brain is a huge pain. Imagine this is a relational database. And we have one master, slave, 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 slave. I did it again. And then network partitioning happens. But you're cool guys, you have failover. So this group B thinks what group A is down. Group A thinks group B is down. Group A is fine because it has master. Group B has no master and it cannot operate, but we have failover. We are cool guys. So this group runs an election and creates a new master. Now we have master, slave, 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 master, slave, 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 isolated from each other. Worst what can happen here, if this master will be available to public and queries will be rerouted to this master. Because after some point of a time, system running like that, you are going to have two completely different versions of the data, some different operations executed onto different fork of your data. Good luck recovering from this situation, because there is only basically a manual way to do it. There is no way to automate it. It's called split brain, and that is a real pain. I dodged this bullet. Split brain never happened to me. That's why I'm not completely bold. So, and then CEP theorem in full. In a distributed environment, in case of emergency, you can have only 2 guaranteed qualities out of 3. We cannot get into the center. We can be, for databases, as we cannot afford partition intolerance, we speak about always consistency to partition, CP databases, or availability and partitioning, AP databases. So you have to decide what do you want to have in case of emergency, in case of some outage. You want to go for availability and partition tolerance, you risk consistency of your data. You go for consistency and partition tolerance, you risk availability of your data. There is no silver bullet, you have to decide. But there is an interesting story to tell in a moment. Is Cassandra AP or CP? Very common misunderstanding. So many people say what Cassandra is AP. My colleagues telling that all the time, I hate them. Nope, Cassandra is not AP. Cassandra is not CP. Cassandra is configurably or tunably consistent. It depends on, depending on the situation, depending on what kind of a data you work with, you can configure it to be AP or CP for different kinds of data. You need, I don't know, you store customer financial data, you need consistency, right? So let's go configure it to be consistent, like more consistent than available. So you can afford downtime, but cannot afford inconsistency. And the same application, meanwhile, stores some, I don't know, user profile pictures. No one will die if you won't get updated what your friend changed his profile picture, right? So we can go for availability here, sacrificing consistency, because eventually it will recover over time. So two tools we need to understand: consistency level and replication factor. Replication factor is obviously pretty clear. Set replication factor to 1, you are fully consistent. Lose this node, downtime, because you sacrifice availability for consistency. But usually that's not what you do. Usually you keep your replication factor number 3. But actually you go with real configuration happens with consistency level. What is a consistency level? Consistency level defines how many acknowledgements you will wait before data is considered to be written, or if we speak about reads, how many nodes will confirm what they have the same copy of the data, so there is no stale data, before the answer is returned. With consistency level 1 and replication factor 3, we will wait for the fastest node to answer. For example, we ask something, usually query goes not here but here, because drivers are token aware, and as soon as it works, boom, we get answer immediately with consistency level 1. If we go for consistency level quorum, so majority, большинство, that means what we will wait for majority of the servers to answer. Your data has been stored, so we write here, those guys confirming what data is persisted, so good, we return to client answer, yes, we are good. All those operations are happening asynchronously in parallel, of course, so we don't wait for first node to answer and then writing to the second one. No, of course, it all happens automatically. As you could guess, 1 is potentially the fastest way to write data, because you answer to a client what data was stored as soon as you get the fastest answer. So before, if you write with consistency level all, you will wait for all confirmations from all servers. And if this guy is busy with garbage collection or whatever shit happening on the servers, sometimes you are going to wait forever. And of course, I forget to connect to my power supply. It's somewhere here. I need a power socket. Oh, it's here. Sorry. Oh, that was scary. Good. But I'm not sure if we have power on the socket. Guys, ребят, с электричеством что-то здесь нехорошо. Есть еще где подключиться? О, давай попробуем. Давай. Так, пардон. Упс. Хороший момент, чтобы взять пиво. Чего сидим-то? Чего сидим? Кого ждем? Непонятно. Здравствуй, Гриша. Я очень тебя ждал. 8 лет не виделись, черт возьми. Правильно, правильно, пролезай. Да давно бы пролез уже, господи. Так. Ну, а я пока обойдусь водичкой. Это ненадолго, обещаю. Так, отлично. Так, давайте потихонечку продолжать. Соответственно, Replication Factor 3, наша первая ручка. Consistency Level All, наша вторая ручка. Oh, okay, yeah. So, yeah, actually it's my dream to do the, okay, thank you. It's my dream to make the presentation in Russian, because I like train a lot of software developers and I do it all the time in English. And I dream once to do this talk in Russian. But okay, so it will happen eventually. So what happens in this situation? What's wrong in this situation? What is the problem in this situation? There are so many bright people, you can guess what's wrong in this situation, because latency, yes, because first of all, well, yes, right. I wanted to explain different thing, but yeah, latency will be a problem, because then you will get not the fastest answer, but the slowest answer, and doesn't matter if those two servers were lightningly fast. If this guy is slow, your answer will be slow, so that's for sure. But there is a bigger problem actually.
Some of those nodes may be down.
Exactly. And what happens? Then some of those nodes are down.
Not all.
Nothing at all. CEP theorem is here watching you, Vazovsky, always watching you. So then you go with consistency level all. You intentionally move from availability to consistency part. That's why I speak Cassandra is not AP. Cassandra is tunably consistent. And you just sacrifice that availability for consistency. Kinda cool, yeah, if you need that. But, of course, everyone asks me, like, we kinda need to have both. We want to be highly available, and still we need to be, like, consistent. So is there a way to get into the center of this CAP thing? Like, we cannot get for real center, but we can get as close as possible. It's called immediate consistency. What is immediate consistency? It's the right way to work with Cassandra. If, like small text on top, if consistency level of your write plus consistency level of your read is higher than replication factor, you have immediate consistency. What does that mean? If you write with consistency level all for replication factor 3, you write to 3 nodes, and you sure data has reached each node. And then you can read with consistency level 1. 3 plus 1 equals 4, 4 higher than 3, you are good, you are consistent fully. Then your writes will be slow and expensive, but reads will be lightningly fast, because then you read with consistency level 1. First of all, your queries normally will hit the replica node, so it will go directly here, for example, and as you declare it consistency level 1 on read, you will get your answer immediately without building a quorum with our servers, without retrieving data for our servers. Consistency level 1 is dangerous, because if your data is inconsistent, you will get inconsistent data. So notice I speak about consistency level 1 only with consistency level write 3, which is slow. We can go opposite way around, write with consistency level 1, read with consistency level all, but it's not the best thing. I mean, like, you're still running into this all problem, that means downtime. So how do we drop that? Consistency level write plus consistency level read, if we go with quorum makes inconsistency mathematically impossible. If we write with quorum of 3 equals 2, so we know what at least 2 servers got the data, at least 2. Then the read data, again with consistency level quorum, we will read data from at least 2 servers. And that's interesting thing happening. Imagine failed scenario, this server didn't get the update, so it's inconsistent. And those 2 are consistent. Then the read data, we will compare two pieces of data. Well, not technically the data itself, but hashes of this data to keep it fast. So client, server here is up to date, server here is up to date, server here is outdated, and we read data. If we read from those 2, so this server answers faster than this one, we see what data is the same, consistency level fulfilled, we return the answer immediately. If this jerk answers faster, then query coordinator sees what hashes are not matching, and then basically we are getting data, waiting for the confirmation from this one. We see what these data is newer, for latest write wins, and we have consistent data. We return it to a customer, and we initiate repair on read. Repair on read means what this node will be informed of its bad behavior, noted, written in a black book, and it will initiate repair for this partition. So data will be pulled from those 2 guys, and consistency is recovered, and guess what? Automatically. Best part, like I can just go drink some coffee and cluster does my job for me. Perfect. So, good. Quorum is basically the best scenario. You're getting as close to a CAP center as possible, and still without sacrificing availability. So that's a pretty cool thing. What query consistency levels do we have? Any, one, local 1, 2, 3, quorum, local quorum, each quorum, all. We spoken about one, quorum, and all. What to notice here? 2, 3, well, that's pretty obvious. You may want to declare like particular count of the data. Any, if you love risk, any is for you. Any is available only for writes, and that means data is considered as persisted as soon as query coordinator gets it. I love risk. For many scenarios, actually, it's a practical thing. If you, for example, you have, I don't know, IoT network of sensor for temperature, or I don't know, factory sensors reporting their state every 5 seconds, and you have billions of those sensors, and you can afford losing one update, then you can go with any. It will be the fastest way to handle this storm of the messages. Okay, but what's important to understand here is local and each. What is local? Very easy. If your application runs in Frankfurt and your database runs in Frankfurt, but you also have instance of application server and database data center in Australia, you want your Frankfurt clients to use which application server? Frankfurt. And you want this application server to use which database? Frankfurt. Simple as that. Local means closest. So it means if you go with local 1 or local quorum, it will wait for confirmations from only local data center, the closest one, so you won't wait for Australia. Each, well, basically means each. So each quorum, I need to reach quorum in each and every data center. But it's going to be slow. Sometimes you need it, sometimes you don't. Question, even 2. Oops, sorry. Yeah. Yeah, great. So, CAP theorem says what on failure? C, A, and P are guaranteed. If C fails, so do A and P. Only CA or CP can be guaranteed. That must be simple, I hope. Everyone has voted. Thank you. And the answer is yeah. Good. Next question. 15 players ready. So, recommended consistency level for immediate consistency. Read write 1-1, read write 1-all, read write quorum quorum. How it goes? Maybe too much time, but okay, everyone has voted. Thank you. So, yes, take a look. 1-1, nope, it's a very risky thing. 1-1 makes 2 for replication factor 3, 2 is smaller than 3. Surprise, mathematics, you're a bitch. So, this is a guaranteed way to inconsistency, sooner or later. 1-all will work, so yes, it's immediate consistency, but it's a risky way because you have all means possible downtime, so it's not recommended. Recommended is quorum quorum. Good.
So replication level 3 is also recommended because in your question there is no mention of replication level any.
Any is definitely not recommended for.
I mean replication level n. It might be 1, 2, 3, 4, 5, whatever.
I mean, like in this case, replication factor size totally doesn't matter. You can have replication factor 3, you can have replication factor 5, you can have replication factor 42. Answer still will be the same. 1-1 doesn't work, 1-all works but not recommended, quorum works because quorum is calculated automatically.
Yeah, but for replication factor 1, 1 plus 1 is bigger than 1, so
oh!
That's
Devastated. Okay, my bad. I'm sorry. Yes, right. 1-1 for replication factor 1. My God, you know, I know how many people saw his slide over the world. Thousands. It's the first time I got on this. Okay, I will improve the slide, thank you. Oh, actually, it's my last talk in my role because I'm moving back to engineering, to development operations more specifically. 5 years, it was pretty great ride, but enough. I need to do some real work now. Good. Oops, wrong size. Yes, I asked 2 questions now, right? No, 1. Okay, good, thank you. So, tables and partitions. First part of this part, of the last part, is going to be very, very short. And last one will be the best, actually, most important. Cell, intersection of a row and a column. Simple, right? I mean, like everyone knows what the cell is, stores data. Single structured data item in a table, which is a row, also familiar to you. Shouldn't be a big deal. But now things are getting more interesting, partitions. I again repeat, I'm talking again about the partitions because it's the most unusual and most important concept of those databases. Story is, if you don't understand partitioning, failure is inevitable. Like, don't forget about the partitions because partitions never forget about you. Good. And then table is a group of columns and rows storing partitions, not rows. In relational databases, you go schema, table, row. In Cassandra, you go keyspace, table, partition, row. If you don't understand partitioning, you are fucked up. Question of time. Good. So data is organized as distributed tables, just a friendly reminder. How do we define partitions? We define partitions with partition key. Partition key consists of at least one, it must present, it's required, it's not optional, but it may consist of one or multiple fields. Examples, we store this temperature by sensor data. So we store, for example, we can group it based on a sensor. All rows within the same partition are stored on the same server, so it makes sense to store together what you retrieve together. It will be one simple operation reading data from one simple server. Looks good, potentially may be dangerous. We can group data, for example, based on sensor and timestamp, so when this record was done. That will create a lot of small partitions. Is that good or bad? There are no simple answers. So take a look. We definitely don't want our partitions to be too big because we run again into the problem we are trying to solve too much data. If we do partitions like that, we will have a lot of small partitions, single row partitions. Is it fine? Yes, it's fine. We can have as many partitions as we want. It's not a problem. The real problem is working with data, you need to think about 2 parts, 2 moments when you write data and then you read data. Can we read these, can we write this data when we store update from our sensor reporting its temperature? Do we know sensor ID? Yes. Do we know timestamp? Yes. So answer is yes, we can store data. But when we are retrieving this data, we are reading data for a sensor XYZ for the last month, for example. Do we know each timestamp of each temperature recording? No. And why is it a problem? We all use it to work with relational databases, basically single host databases originally. They're all data stored on each particular server. And many people don't understand why partition key is a problem here. Answer is very simple. Let's say we have not a single server, but 1,000 of the servers. And some of them for sure store this information. Some of them, of 1,000. How we are going to retrieve this data? There is only one way. Go, if we don't know all the parts of a partition key, we have to literally go ask each and every server you have. So Apple runs 300,000 servers. It's not going to be fast. Mostly probably you're going to switch to Android finally. So we cannot retrieve data like that. Technically it's possible with special keyword allow filtering. The only thing you need to know about allow filtering, do not use allow filtering. The allow filtering will allow you to run this request, otherwise you would run into an exception. Good. So maybe you aren't going to read data like that. Maybe you're just storing it and this scenario is fine for you. Or maybe you always know timestamp, then it will work. But in general, full cluster scan is definitely not what you want to do on production. By the way, if any of you are responsible for CI/CD, for kind of a software code quality checks, I beg you, if you work with Cassandra, please have checks on the allow filtering statement in your code base. Because like today you have a highly qualified team, everyone is happy, everything works shiny. Tomorrow you hire a junior, which like, oh, I will use Cassandra, boom, 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 query doesn't work, use allow filtering, it helps, allow filtering, oh, works, ticket closed. 3 months later, your database is down. Why? Because you didn't code this thing. In the Cassandra version 4, there is a guardrail which allows you to switch off or at least raise warning on each use of allow filtering. Full cluster scan is bad. Good. So, first part of a key is a partition key. Very important thing to understand. Second part of a primary key. First part of a primary key, second part of a primary key is clustering column. Clustering column defines sorting order. That is a very interesting trick. Normally, in relational databases, for example, you sort your data on retrieval time. So you're going to retrieve data sorted by this and that property, and it's done on a read time. Cassandra is pre-optimized. So data is pre-sorted. Then you read data, it will be sorted already, so there is no need to execute sorting. It's done already on the write time. Very interesting technology, we will discuss later. Very interesting approach, we will discuss later in a bar, if you ask me. So, what's the problem with this key, for example, would be without clustering columns, the primary key will be just sensor, so we will always have one record per sensor. It might be what you want, but if you don't, then this key will not work. You need to add clustering columns, because clustering columns help you with uniqueness. So, sensor and timestamp, that will work. Timestamp is a clustering column, so data will be sorted by time. Sensor value timestamp, yes, but as clustering column defines sorting order, then data will be first sorted by value and then by timestamp. And that might be what you want, or might not, depending. And then sensor date timestamp, so we have good grouping, we have kinda, sorta, proper partitioning, and still it's unique because of the use of a timestamp here. Good, and in this case, so sensor date timestamp, for example, is the partition key, clustering, and what is value then? Value is a data column. Why I'm talking about value, why I'm talking about data columns now? Because here comes one of the typical Cassandra pains. If column is not mentioned in a primary key, you cannot sort, search, you cannot do anything. Data columns are just to store data. You cannot search, you cannot sort, you cannot do nothing with them. There are secondary indexes. Yes, but again, we speak about partition data. So we have secondary indexes. Yes, those work per partition, not per the wall table. If you need like to have a real indexing of all your data, you need to stream data somewhere else. But well, it works on all the continents lightningly fast. So kinda, yeah, suffering is a choice. So, then primary key, two parts combined together, responsible for uniqueness of a data. That must be pretty simple. Good. Now, why I'm talking so much about that? Take a look. Partition keys define data distribution over cluster. If we would change a partition key for a data, like if we change, data model like table, I wanted sensor ID to be my partition key now, or I want sensor in date to be my partition key. It will lead to what? Partition key is different. Murmur free hashing algorithm. Cat is happy. Murmur. Token is different. Different server responsible for this data. data streaming is happening for all the fucking cluster, and you are dead. So, partition key define data distribution over cluster. You change data model, you have basically to rewrite all your data from one server to another. It's not going to work. Clustering columns define how data is physically stored, written on disk. Change clustering columns, data has to be rewritten. All data for your cluster, for all the disks. Guess what? Not possible. Once created, data model cannot be changed at all, completely. You will need new tables and you will have to migrate your data. And yes, it's a real problem. It is a real problem. For many databases, you could go with change data capture, for example, but change data capture for distributed data is painful, again. So enjoy the money and learn how to not suffer from it all. Yeah, we have a lot of work. So, alter table, add season text. For example, we are adding data column. Is that possible? Yes, it's possible. Are we going to change any part of a primary key? Doesn't work. Schema is immutable. And frankly, guys, it's a pain, yes. Good. So, final part, just 3 last slides. Okay, a little bit more, but we are finishing. You must understand partitioning working with Cassandra. If you don't, you are in the troubles, your business in the troubles, investors are not happy, investors can go to hell, but still, you know, they give you money. So let's try to keep it fair. First rule of a good partition: store together what you retrieve together. There is a YouTube video, and each video has some comments. We want user opens this video, and we want to show those comments. It makes sense to keep them in a single partition, so we can grab all of them with single query asking one server, not a dozen of servers. So we can go, for example, with partition based on video ID. And then we know video ID, customer opens video, we go with this video ID to the server, server returns us data. Works. If we would go for each single partition, single row partitions, each partition per each comment, then obviously they will be placed on different servers. And what happens then? We have to ask basically thousands of servers. It's not going to be fast for sure. Then, okay, this concept must be simple. Store together what you retrieve together. Then, avoid big partitions. That is the core thing. They are doing partitioning to avoid too much data per server and be capable of scaling. For example, this example is actually not so great because some comments or some videos on YouTube, they have like people are crazy. There are millions and millions and millions of comments. But the story is comment per se is a pretty small unit, right? So there will be ID, there will be text, author ID, we go with the normalization, so author name, but still it's some text, so it's not so big deal. If we go with dividing users by country, and there are countries like San Marino, and there are countries like China. It makes uneven partitions, and uneven partition is very bad. Because, well, it doesn't scale. And hard limit is up to 2 billion cells per partition. It's only hard limit. DataStax recommends to go with 100,000 rows in a partition, 100 megabyte in a partition, and we do our best to inform anyone what those are recommendations. Those are like doctor recommendations. You can ignore them, but after some time you will be very sad about your decision. I asked once our data engineering team what was the biggest partition they ever saw. Answer was 15 terabytes. It was slow. So, yeah, recommendation of 100 megabyte, you can imagine. Good, and finally, question here. It's a real story from our real customer. I won't tell you the name. Well, it's kind of under contract. I shouldn't discuss this kind of things, but well, anonymously, very good example. Huge IoT infrastructure. You definitely know the company. Hardware all around the world, different sensors reporting their states over time, every 10 seconds. Each sensor reports its unique ID, timestamp of a report, and sensor value. So they decided to build their data model like this. Sensor ID, reported at. Store together what you retrieve together. Sounds good, right? They used to retrieve data as it is, so it makes sense to group it by sensor. It all went good and green in the beginning, then some shit started to happen. What was that?
Too much values.
Yeah, right. So each partition grow over time, constantly growing partitions, right? There are two ways to handle this problem. First of all, Cassandra has so-called TTL mechanism. When you store data, rows, actually even more than rows, just the columns, just the cells, particular cells, you can assign TTL. So time to live, and data will be automatically deleted over time. Pretty convenient thing. Especially for like big data, or if you don't need after 1 month, for example, it just will be wiped out automatically. But then there is one more thing, which is better, bucketing. Our customer needed to store this data because of legal reasons for 5 years at least, so TTL wasn't a big solution. Bucketing is introducing of a synthetical value, not so synthetical in this case. Very often it's just completely randomized. In this case it's not really synthetical. We are using month, year as an integer, as a string, to group data into smaller chunks, into smaller partitions. Sensor ID stays the same. Month, year is pretty good here. So for example, now it's last day of May. Oh, last day of a spring? Interesting. It was pretty great spring to me. Hope for you as well. So month here will be 05, 20 to 3, or 20 to 3, 05, whatever you prefer. For us, it doesn't matter. And reported at stays clustering column for sorting and uniqueness reasons. Many people ask, why wouldn't we just go for timestamp here, or not a month here, but a week, or maybe even day, to get smaller partitions? Take a look. As said before, creating data model, we need to think about two things. Moment when we write, moment when we read. Again, if you will write data like sensor ID, reported at, or timestamp, can we write it? Yes, we can. Can we read it? No, we cannot. Sure.
Why we can read this if timestamp is index bigger, equal, and smaller, equal?
Good. So, thank you, by the way. It's a very good point. Inequalities are not possible for partition keys. Partition key are available only with exact number. You cannot build inequality over partition key. You can use inequalities bigger than, smaller than for clustering columns because they are sorted. With partition keys, no. You have to always give explicitly all the parts of a partition key. That's exactly why I said that partitioning solves some problems and introduce actually even more. But, well, it solves problem of scaling. If I didn't answer, we can discuss it later in details. Now I want to move on. Yes. So, can we go not with timestamp, but for example, when we will have buckets per week? It's fine-ish. So maybe it's exactly what you need. You have more data, not every 10 seconds, but I don't know, every second or many times per second, also fine. When we will need smaller chunks, it depends on your case, but the general idea is you need to handle it properly and think about that. If you do chunks too big, you will slow down your cluster. If you do your chunks too small and you need, for example, base it on a week, and then you have to retrieve data for 5 months, you will, select statement will be like select blah 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 sensor ID XYZ, and then week 1, week 2, week 3, week 4, blah 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 blah. So it's not going to work well. Keep partitions of a reasonable size. And basically, last thing, avoid very last part of this presentation, avoid hot partitions. I mean, like, hot sounds kind of cool, but not until it's not. If we store data like sensor ID and month year, we will have plenty of partitions spread it over cluster. Now imagine we have data based on this date, current date, and sensor ID. Then an interesting thing happens. Imagine we have 100 servers, and we have data model like that. And it's quite a pressure. We have more and more sensors, so we have a lot of pressure. But well, we are a big company, we can afford, we buy 100 more servers, add them to a cluster. Does that help? Does that help?
It goes
Sorry?
to a single partition.
It still goes to a single partition. All the workload goes to a single partition. You can buy 1,000 of a service, it won't help. That's exactly what I meant in the beginning. Guys, Cassandra scaling is a shared responsibility. It's on Cassandra and it's on you. And Cassandra does this job well, so should you. This won't work, that won't scale. Whatever, how many clusters do you, how many servers do you add, it won't help. You just always have all your workload going to a single server or free servers if it's a replication factor free. Last question, and we are done. First one. Select without partition key. Syntax error. Okay to get all data. Very bad, illegal, and punishable by law. I'm working now to create NoSQL police, so we will go and arrest you if you are trying to use select without a partition key. It's illegal and punishable by law. So, I love you. Who did that? Who did that? Thank you, everyone. It's great. Very bad right answer. Okay to get all data. Oh no! Someone is thinking relational here. Guys, all data can literally mean 100 petabytes. Literally. Good luck. Make your boss happy. Do it, do it, do it. Then syntax error. Sadly, no. It would be great. If you are trying to select without all the parts of a partition key, there are two scenarios. You don't have where at all. When it will be executed with a hard limit of 100,000 rows, and it's pretty bad. So if you use where, then you will just get an exception. You cannot do it. Use allow filtering to solve the problem. Cassandra lies to you. Do not use allow filtering. Rethink your data model. So it's not a syntax error, but it should be. So technically it's my dream come true answer, but nope, it's not. Well, with guardrails, it will be. So if you're running Cassandra 4 and have proper guardrails configuration, it will be error. Not syntax error, but still. Good. And last question. As always, I'm over time. What is the most important rule of partitioned data? Try to have as many partitions as possible. Keep partition size under control. Keep together what you retrieve together. Make partitions bigger. Everyone has voted. Thank you. So, yes. Again, trick is in the details. Most important rule. Take a look. Keep partition size under control. Keep together what you retrieve together. Both are rules. And well, this rule is important. But I'm speaking about the most important. If you distribute data, breaking these keep together what you retrieve together, for example, breaking data into buckets, you will have to ask as many servers, as many partitions you are trying to reach. It's not a big deal if you are trying to reach 3 partitions, because these will be done in parallel. It's pretty quick. And in the end, you still can just like retrieve data, maybe not the most convenient way. But then your data model was wrong. And then you already uploaded a couple hundred petabytes of data, and data model is immutable. You're going to migrate all this shit. And well, or you're going to have downtime, so stop writing, unload data, load data, running again, downtime, everyone is unhappy. Or you are going to have real troubles doing dual writes, migrating some data in the background, so it's really a lot of work. So the most important thing, keep partition size under control. Never forget about partitions. Was it the last one? Yes, it was the last one, so leaderboard. Zlatan, Twitter, NoSQL schema. Thank you. So, who is Zlatan? Congrats, sir. Yes. Zlatan, Arseny, Pingo, Twitter, everyone, congrats. It's a great job, totally great job. Zlatan with football ball, that must be Ibrahimovic. Okay, so good. That's, sorry?
What is P? It is points. Points.
It's not rubles.
Pounds maybe.
Not pounds, no. It's like bags of nothing. Yeah, we have a lot of bags of nothing. Yeah.
Maybe it's pain.
Maybe it's pain, yeah, maybe like, but with a lot of pain is inevitable, suffering is a choice, but with a lot of pain, working with distributed systems like that, you get better paid. So yeah, maybe in the end it will be pounds. I guess would be better than rubles. Yes, so, but everyone, if you're on the leaderboard, congrats. If you aren't, still you invested your time well. Oops, wrong slide. Yes. What's next? Stay in touch. Even without me, DataStax developer relations keeps running. Hopefully not as successful as it was with me. Guilty pleasure. So Discord server, DataStax Academy, it's open, free, available to everyone. Courses on Apache Cassandra, that's just a little, this talk today is just a little scratch. There are like 20 hours course you really can get for free, and even better, DataStax sponsors your certification. So if you get this course, you get a voucher, usually from me, but not anymore, but still I can get you some. We have friends in different departments. So I can get you some vouchers to get certified, take the exam, hopefully pass the exam. You are not ready for the exam right now. I mean, like, shit is pretty serious there. We run online workshops usually twice per month. Looks like now, I'm not sure if it will be happening anymore, but maybe, who knows. And DataStax Developers YouTube channel. By the way, as we have a lot of Russian-speaking people here, I also have data modeling workshop dedicated on data modeling in Russian language. Same channel, Cassandra Day Russia playlist, also done by me, and very much recommended if you're getting ready for the certification or going to work with a system. With that, it was me, IT exorcist, developer advocate lead, head of developer education, former, now developer operations engineer. Thank you so much, and contact me with LinkedIn. I will be happy to meet you.
Woohoo! Алекс, спасибо тебе большое за такой подробный доклад. Я знаю, что ты решил говорить все-таки на английском. Спасибо тебе за это отдельное от всех тех, кто не понимает.
Мы никого не должны исключать.
Супер. Если у кого-то еще остались вопросы, самое время их задать. Можно задать через микрофон, чтобы те, кто слушает стрим, тоже все услышали.
Раз, два, три. Хотелось бы еще раз поблагодарить за такое подробное интересное выступление. И у меня два вопроса. Первый, как стать контрибьютором в какую-либо open source систему и таким почетным контрибьютором, и этим можно хвастаться и гордиться, ну и как из нее тебя могут выкинуть и выписать. И второй вопрос, рекомендации по тому, как правильно писать архитектуру БД, то есть есть ли какие-то гайды, книги, что-то для advanced.
Я сначала отвечу на второй вопрос. Best book about database architecture is written by Aleks Petrov, Belarusian guy who is like just, his brain is of the size of a Texas, really. A very good book named Distributed Database Architecture. This one is not only about, first part of the book is dedicated to slowest operations on how you work with the data on disk, because it's like a really advanced thing if you want to work with a lot of data fast. And second part of a book dedicated to exactly the distributed system things. So for database architecture, I would say it's the best book, yeah, Distributed Database Architecture by Aleks Petrov, something like that. I don't remember exact name of the book. About the first one, it's a little bit out of scope for this, so I will keep it till the end if you don't mind, or we can discuss it later in a bar.
Okay, the second option is good.
Yeah, but it's a great question. As an open source fan, I'm totally with you, and that's a really great question. It's just a little bit out of scope. Что-то с микрофоном.
Hello. So two questions. Finally, is Cassandra relational or what? Or maybe configurable?
No. Cassandra is strictly non-relational. There are no foreign keys. There are no relations from one partition to another, from one table to another, for a very simple reason. And they never be, I would say. So with Cassandra version 5, Cassandra is going to be ACID compliant, and that is a fucking blast. But it's strictly non-relational, you see, like Cassandra goes on denormalization instead of relations. It's a huge win for the performance, because when you do denormalization, you read your data easily, and write data, you have to like update multiple different places. And it looks like a problem. Well, it is a problem. We have potential cross-table inconsistency, but multiple writes can be executed in parallel. So very quick. And then you have relations, and then you have a select query with a join, or not with 61 join, okay, but even with 10 join. In most of the cases, those joins cannot be executed in parallel. You do first join, you do second join, then you do third join. It comes, wait a moment. And in the end, like they're executed sequentially. So basically, a relational database working with big data just cannot be fast, technically. There are so-called new SQL databases that distribute data over servers, over different regions, and say we are distributed SQL. Is that work this way? Yes, it is. Is it going to be slow? Hell yeah. So Cassandra is non-relational.
Well, and another question, is Cassandra works for no big data?
Yeah, sure. So, for example, I work in Germany. One of the German institutions, healthcare institutions, using Cassandra Alpha, they're a single region, so they aren't having clients in Australia, and they aren't really into big data. We see discussing requirements we discussed in the beginning. They have extreme requirements for high availability. They need 100% uptime. They cannot afford 9999 because it means someone is going to die, literally. So yes, there are some scenarios when you want to use Cassandra not for big data, but still for some other reasons. High availability, for example, but only one of them. Yeah?
Спасибо за очень интересный доклад.
Мое удовольствие.
И мой вопрос о масштабировании. Когда мы масштабируемся, добавляем сервера, то пересчитываются токены, но данные же лежали в этот момент на других, на тех серверах, которые были. И еще интереснее, когда мы наоборот убираем сервер. Данные лежали на серверах, которые мы выключаем, и они должны как-то перейти на оставшиеся. Как это происходит?
Да, происходит стриминг данных. Это очень интересный процесс. Он автоматизированный, но вы должны дать на это добро, потому что если у вас добавляется одновременно, там удваивается размер кластера, вообще это в целом очень не рекомендуется делать, то у нас кластер будет занят не ответами клиентам, а стримингом данных, что очень плохо. Причем раньше, до версии 4, это была вообще отдельная боль, потому что оно все сначала сериализовалось на одном сервере, перегонялось на другой, потом десериализовалось там. Вот. И там, конечно, это была очень дорогая и печальная вообще история. Netflix это достало полностью, прям, то есть они вообще от этого страдали. Я спрашиваю у Netflix, ребята, как бы, а сколько у вас серверов-то вообще? Говорят, да мы не знаем. Ну, там что-то нарастает, что-то отрастает, оно само, там, самоопылением, все автоматизировано. Мы не знаем, сколько у нас серверов. Ну, 1070 примерно, как бы. Вот, вокруг этого гуляет. Соответственно, если здесь еще интересный разговор про data density, как много данных ты имеешь на сервер. Соответственно, некоторые компании гонятся за большим data density, и они хотят там иметь прям гигабайты, терабайты на каждом сервере, больше, типа так получается выгодно по деньгам. Да, но нет. Потому что чем больше у вас данных на сервере, тем дольше они будут стримиться. Значит, тем менее гибкая ваша инфраструктура. Соответственно, у Netflix data density очень низкая, потому что им выгодно быстренько нарастить там еще 100 серверочков, потом также быстренько еще 200 убрать. Поэтому они хранят мало данных per сервер, чтобы эти данные потом быстро гонять туда-обратно. Это процесс стриминга, он полностью автоматизированный. И, собственно говоря, да, в версии 4 вышло очень серьезное обновление, вот Netflix, собственно говоря, выпиленное, что данные стали перегоняться в виде sorted string table files, просто as is. И по сути, там все решили проблему, добавилось новое, оно стримится настолько быстро, что у нас сеть забивается. Вот, когда новый сервер стартует, ввели дополнительные параметры в конфигурацию замедление операций стриминга, потому что она теперь слишком быстрая стала, а мы так быстро не хотим, у нас сеть начинает умирать. Вот. Ну вот как-то так, да, то есть четверки для некоторых типов компакции. Про компакцию мы сегодня не говорили, потому что лекция для колхозников, в смысле для разработчиков, а компакция это больше про operations. Про компакцию я тоже могу рассказать, там много интересного, там зомби всякие, много вообще интересных вещей происходит. Вот, ну, в общем, да, я надеюсь, я ответил на вопрос про стриминг. Могу рассказать в подробности там позднее.
Спасибо.
Угу, там.
Можно я задам вопросик?
Да.
Да, спасибо большое за доклад.
Мое удовольствие.
Очень хорошо и красиво звучит, как почти с любой базой данных, правильный, красивый рабочий сценарий. Да, а вот очень бы хотелось услышать, в принципе, как и с Динамой, вот если мы все-таки получили этот split brain, и там часик позаписывали с одной стороны, часик позаписывали с другой стороны, и у нас там миллион транзакций в секунду, мы Netflix, и вот потом как бы оно уже не split brain. И что делать? Руками типа мержить каждую запись?
Смотри, если мы говорим конкретно про ситуацию split brain, то да, руками мержить. И да, это... Вот, то есть, да, именно так все плохо. Сплитбрейн это то, чего нужно очень избегать. С Кассандрой все чуть-чуть сложнее, потому что мастеров нет. Sorry. Yeah, question was in Russian, so I started to answer in Russian. So with, okay, I will finish this one in Russian because it just makes no sense to switch to English now. Next one will go in English. С Кассандрой про сплитбрейн немножко интереснее, потому что у нас мастеров нет. Тем не менее, ситуация такая может произойти. Это не будет в чистом виде сплитбрейн, потому что сплитбрейн подразумевает мультимастер. Но так или иначе, у нас есть дата-центр, предположим, один для простоты. У нас там кусок дата-центра отвалился, изолировался от второго. Они друг с другом не могут взаимодействовать, но могут взаимодействовать с клиентами. При этом клиенты-то про них знают, и клиенты к ним ходить будут. Там даже фейловер не нужен. Мы, в принципе, теоретически легче влетаем в эту ситуацию. А дальше все зависит от consistency level. Если мы отмотаемся сейчас на тот слайд, это классный вопрос, который я действительно хочу осветить. Если мы отмотаемся на CAP, где она там у нас? Господи, да, вот. Смотрим, у нас часть данных пошла сюда, часть данных пошла сюда, допустим, записи. Предположим, мы пишем с consistency level all. Если у нас запрос идет сюда и все реплики здесь, запрос будет исполнен. Если не все реплики, если реплики разнесены по группам, запрос не будет исполнен, потому что мы не можем достигнуть all. Если мы пишем с quorum, ну, по сути своей то же самое. Мы можем достичь кворума в рамках одной из групп? Можем. Здесь для группы A мы кворум достичь можем. Для группы B почти никогда. Потому что, ну, только если у нас два сервера отвечают за эти данные здесь, и третий здесь, вот, то, соответственно, эти сервера будут обновлены, этот не будет. Почему? Потому что он недоступен. Но здесь интересная штука. Мы пишем кворум, у нас не возникает сплитбрейн. Никогда. Потому что либо запрос будет исполнен здесь благополучно, либо здесь он не будет исполнен, а мы об этом знаем, то есть клиент об этом узнает, скажет, не удалось сохранить данные, окей, устраивает. И если мы записали сюда и запрос прошел успешно, то у нас не возникает сплитбрейна, потому что этот не обновлен, но с него данные не будут считаны, если мы читаем на consistency level quorum. Все, проблема решена. А если мы пишем на one, читаем на one, то мы самым прекрасным образом влетаем в сплитбрейн. потому что у нас данные могут рандомно читаться из разных изолированных групп. Добро пожаловать в ад.
А если чисто физически, как там, условно, в Netflix у нас миллион нод, мы же не ожидаем типа, одобрения от миллиона нод, мы ожидаем от предположения
Ну да,
5.
да.
И вот, как бы, вот этих 5 сплитанут.
Вот, во-первых, у них там, да, 70 тысяч серверов, но это несколько кластеров. То есть у них крупнейший кластер, по-моему, 1000 нод. Или около того, я не помню точно. Может быть, как раз вот в том видео, про которое я говорил, об этом говорится. И скорее всего, если ошибка все-таки произошла, где-то мы не досмотрели за джуном, условно говоря, да, и у нас там пошел consistency level 1, allow filtering, вот. Ну, как говорится, если дурак джуниор уронил продакшн базу данных, то дурак там совсем не джуниор. Вот. Слушай, честно, я не знаю, меня боженька миловал, как бы я с этим не сталкивался. Вот. Могу поговорить с нашей Data, господи, Field Team, они там страшные вещи повидали вообще. Вот. Так. So we will switch to English.
Okay. So imagine we designed our partitions well, but we thought about that, but then I don't know, our partitions became to grow dramatically. We had 1,000 clients and we got million.
Yeah.
And what to do?
Actually, it happens all the time because just business requirements changing. So answer is yes, it will happen eventually. If your business runs on Cassandra, it will happen. Guess what? You know the answer already. And try to enjoy your pain.
Okay, so no special special ideas for...
There are tools to solve it. So, for example, recently DataStax open sourced zero downtime migration tool, which kind of helps with this problem with the dual writes. It's basically a proxy node in front of your cluster, which works like a normal way. But it streams your queries to a real cluster and new cluster. It's designed originally for migration data from one cluster to another, or from Cassandra cluster to DataStax cluster. It's Cassandra as a service. And the same idea, you could use this proxy to do dual writes and run, execute, unload, and load the data in the background. So you will have zero downtime, and you don't have to rewrite your application for that. Or at least not significantly, and still have this dual write cool feature with no downtime. But this tool is designed for, well, migration, not exactly change of a data model. Yes, yet I will try to speak to our guys, like maybe we could adjust that, because this is a huge pain, frankly. But yeah, short answer is there are tools and ways, there are painkillers, but you're still going to have some fun.
Okay, so sounds like concurrent migration, right?
Yeah.
Thank you.
Okay.
I would like to return to split brain situation.
People excited about it, I see.
When we write with quorum and write to first and second servers. And after that we would like to read, and our network situation is changed, and we have available only, for example, second and third. What will be?
Just a second. So, yeah, first of all, then we execute any write or read operations. When we execute write operation, data will be sent to all the servers. So it's like a very common misunderstanding. People think what consistency level, it's not about your question, just my personal pain. People think what consistency level means how many nodes are getting updated. Complete bullshit. All nodes are always getting updated. Just some might not get the update. Then we write to replication factor free, whatever our consistency level be, all servers will be tried to reach and update, put this update into place. If CL is reached, then positive answer returned to client. If it's not, it's not. But the point is, Doesn't matter a network situation or anything. Or you reach the consistency level on the read time, then you get your up-to-date data. If you don't reach, you get warning exception, what like cannot reach desired consistency level. And yeah, that's the story. If we quorum, two nodes were updated, we are reading from them, CL is reached, we are good. If we cannot reach, for example, those two nodes at all, CL cannot be reached, exception. If we can reach only those guys and they are storing different information, CL not reached, exception. Because this one is outdated, this one is up to date, hashes don't match, no answer, I cannot reach desired consistency level.
Could we add some token, version token, for example, timestamp or version ID, and решить эту ситуацию?
You see, the only basically way to do so is to decrease consistency level quorum, decrease consistency level, and some teams are doing that. So they start, for example, with local quorum or local all, getting an exception cannot reach, then decreasing consistency level, local quorum, asking again, then decreasing again to local, I don't know, whatever one, then switching from local to whatever consistency level, what lets Cassandra Driver to reach any other data center, these kind of things. But those things are basically getting dangerous, and that's a not recommended way, because when you decrease consistency level, you pay for it with potential inconsistency. I'm not sure I get the idea of some kind of a token, additional idea how it would solve the problem. I mean, with replication factor free CL quorum, if we have two replicas available, we get the data. If we do not, then do not. For network isolation, answer is still the same. If we have network partition, if we can reach consistency level, then no. So there is technically a retry mechanism. So for example, when client tries to reach this server is down, then it will automatically retry this query again on another server. That would work. But the problem is it's not a network unreachability. It's cannot reach desired consistency level. So I don't remember this part of a driver, but most probably it will just fail to exception and say like I cannot get this data, it's not available at the moment, cannot reach desired consistency level. Most probably it will work like that. I'm guessing. It's quite a huge code base. If I didn't, if you want to discuss it later, we can discuss it later. Yes.
Hi. First of all, thank you for presentation and speech. And
thank you.
I want to ask about cloud databases like Snowflake and BigQuery. What do you think it can replace NoSQL databases in the future?
So, first of all, Snowflake, BigQuery. Take a look. We are comparing very different. That's always happen when you start to speak NoSQL. You are trying to group ungroupable. BigQuery is a great database, great proprietary database, and proprietary databases will never replace whatever open source databases, because many companies just have a very strict rule: we never go with vendor lock-in. If we go, for example, if you go with BigQuery, which is a Google table for like analyzing of a big data, if you go with Google Bigtable, which is a Google clone of Cassandra, based on the same white paper, BigQuery and Bigtable are two different databases, don't mix them. Bigtable is close to Cassandra. It's cool. It has very great, totally great integration with all the other Google Compute Cloud services, so it's a cool thing. As long as you stay with Google, you will be happy. Until the moment you want to migrate to AWS, and now you will have to rewrite half of your application. So that's to answer the story between proprietary and open source databases. Basically, how DataStax makes money? We run managed Cassandra, open source Cassandra, in a cloud, serverless, all cool. But do we do it in our cloud? Nope, we do it in your cloud. AWS, GCP, Azure, maybe some more in the end. It's called a DataStax Astra. We cannot call it Cassandra because Apache Software Foundation gets very nervous when you are using their trademarks. Well, for good. And you can choose the cloud of your choice. You go to AWS. Now you are unhappy with their prices for whatever data storage. You want to migrate to Azure. You push the button, your data being streamed. New data center launched in Azure for you. It joins the previous data center. We stream data. We take down the previous. Basically, you push one button, wait for some time, boom, you migrated to a new system. There are some complications what people who work with clouds understand. For example, like you won't be able to use this private link thing, for example, like in AWS, but yeah. So, it's a good question, so I'm getting to white, sorry. First, proprietary, open source. Proprietary will never replace open source. Second, BigQuery is for OLAP workloads. Bigtable or Cassandra is for OLTP workloads. Can you replace Formula One car with a truck? Nope. Well, you better don't. Answer is you better don't. Maybe you can, but you better don't. I hope I answered.
Еще кто-то? Или уже в бар? Нет, нет, никакого бара.
Ну, слушайте, я пиво хочу. Сейчас, секунду. Так, Хайнекен это не пиво. Ну, сейчас. Вот. Да, я внимательно слушаю.
Как происходит обновление мажорных, минорных версий?
Я бы сказал болезненно. Okay, in English. Will you repeat or I should repeat the question in English? Can you, okay, I will repeat. Okay, I will, okay, then I will answer in Russian, otherwise it makes no sense. I will answer to everyone except the one who asked. So, in general, software update of a database in the minor versions is extremely simple. Because your data is replicated, sometimes multi-region replicated, you just go and do rolling update, rolling restart of a database, and that's as simple as that. Rolling is an important part. You understand rolling? Oh, так. I started to speak English? So, да, Russian. Обновление происходит очень просто. Поскольку у тебя есть несколько реплик часто в мультирегионе, то есть в нескольких дата-центрах, мелкие вещи обновляются очень просто. Здесь единственное, что тебе нужно следить, что это был роллинг апдейт, то есть несколько серверов, чтобы сервера обновлялись по очереди, а не одновременно. Потому что если у тебя все три реплики уходят в ребут, downtime. Вот. Если мы их ребутаем по одной и ходим на них только с не выше, чем кворумом, то, соответственно, все будет хорошо. Вот. Ну и все. С мажорными апдейтами бывает посложнее. Вот, а поскольку мы говорим про системы, в которых 1000 кластеров, например, часть Apple до сих пор живет на Cassandra версии 2, которая вообще-то была выпущена типа так году в 12-м, что ли, и она прям совсем отсталая от жизни, там даже Cassandra Query Language нету, там еще Apache Thrift используется для работы с данными. Вот, да, то есть... Ну, а дальше, да, боль неизбежна, страдание — это выбор. Идем, обновляем ручками, молимся.
So, and yeah. I guess last one from me. So thank you for presentation one more time.
Спасибо.
And you have said a lot of clever things, but the last stupid question from me. So we have, as you said, have to specify a database, like we have a key value database, for example, Dynamo, a document database, for example, Mongo, yeah, and why the Cassandra is column database? Where is the column there?
Okay. So it's a great question, by the way. The story is how do you structure, organize, and write your data on disks? It's like exactly explain it in the book I mentioned recently, Distributed Database Architecture. So Cassandra, normal is a wrong word. Traditional relational database mostly write data on the row basis. Cassandra writes data on a column basis. It's like about how particular write operation is happening on disk and how data is structured when it's written on disk. So it's organized into columns, clustering columns, term columns comes from the same place. So yeah, in short, that's the answer. In this part, I can't go much deeper because like this part of Cassandra I never touched by myself.
Sounds like low level. Thank you.
So?
Нет?
Замечательно. Спасибо.
Спасибо большое. Кажется, было очень интересно. Я ничего не поняла, но вы молодцы.
Они шикарные вопросы задавали и потрясающе отвечали на мои вопросы.
Ты доволен тоже, да, этими ребятами?
Я очень сильная команда прям.
Да, Батуми такое. Суперхаб. Спасибо тебе еще раз большое, Алекс, за выступление,
Спасибо.
за то, что нашел время, выделил его, сразу с самолета приехал и так
я
четко
не
это все создал.
Я прямо с мотоцикла, а с самолета я в пятницу и с тех пор непрерывно еду.
Откуда ты приехал на мотоцикле?
Сегодня утром был в Вони, север Грузии.
А туда?
А туда тоже на мотоцикле.
То есть у тебя турне?
Да, у меня турне.
Потрясающе. И ты так совмещаешь его заодно с какими-то великими делами, да?
Встретиться с умными людьми, попить пиво. Как бы,
Пива еще, кстати,
еще
много, так что угощайтесь, да.
Мы сейчас дам.
Что ж, ребята, мы вас ждем на наших следующих митапах. Они у нас всегда очень интересные и всегда классные спикеры. И теперь, пожалуй, в бар, да? Спасибо.
Супер.
А в какой бар мы пойдем? Мы можем пойти в Quiet Woman Pub, он вот здесь вот неподалеку, чтобы все знали, где он. Quiet Woman Pub.